First company up today is going to be QuantumStack. And while they get mic'd up, let me give you a little bit of an overview of how the day is going to go. We will have a series of 15-minute presentations today, and about the second or third one, we'll take a bio break. We'll break after that for about an hour, and then we'll have in the room across the hall a series of tabletop discussions where everybody will have the opportunity to meet with the entrepreneurs one-on-one for a more in-depth discussion. This morning, these 15-minute presentations will run in a format where the company presents, and then there'll be time for about 10 minutes of questions and answers. So we ask that you not interrupt their presentation because there will be time to ask them at that time. And with that, we'd like to introduce QuantumStack.
Thank you, Tom. Kira, thank you and your team. You've been amazingly helpful in getting us on the right track. It's a tough job managing cats, and I think y'all did a great job for us. And I really appreciate, Mark, the pitch. That was very inspiring. Thank you so much for that. We'll be thinking about that a lot. Let me introduce QuantumStack. My name is Frank Byram, and I'm going to do something similar. I want to start with a space movie or a science fiction movie, and I know that I'm doing this in a room full of people who actually make science fiction real, and that's kind of humbling to be here, but that's really what you've done for me, a kid who grew up watching the Apollo land and all the tremendous things that have come. So let me start with a quick clip. Let me give you an introduction. It's from The Martian. But this is my unsung hero in The Martian, not the astronaut. He did a great job and whatnot. But I want to show you my hero. It's a secret. Don't tell anybody.
Rich, what the hell are you doing? I need you to get me some supercomputer time. When did you last sleep?
Well, let me tell you what happens here.
It's important, right?
So here's what happens is, if you know the movie, there's an astronaut stranded on Mars. The rest of the crew's on the way back, and you have this scientist sitting in the room, and he's thinking big thoughts, trying to figure out how to get him back. You know, what can you do for this guy on Mars? And at this point in the movie, he comes in, and the boss comes in and says, he says, I got the answer basically, but I got to have a supercomputer. I need time on the supercomputer. That's what he says at this point. And so 4 weeks later, after waiting for the supercomputer, we have this scene. Is it Pleiades? NASA supercomputer. He's doing what us computer people do way too often in life. He gets his answers. And in fact, the reason I think it's a great hero story for me as a computer scientist is he got the answer, and ultimately we know the story. They go back, they get him, they bring him home safe, and all ends well, which we love happy stories. So I need you to give me some time on a supercomputer, and that's really what QuantumStack is about helping people get time on supercomputer. So really what we're looking at is we are a crowd-powered supercomputer. And really what we're trying to do is bring together two real great trends that have happened in the internet. The first trend is the crowd. We've seen it happen all over in the use of the crowd and crowdsourcing. That's the first big trend we've seen. The second big trend that we've seen that's up and coming and still emerging, and that is digital currency and the technologies behind digital currency as a method of payment. So those are the two trends that we want to bring together. And the question is, can we do that? Well, let's think about what's happening. We had newspapers. I remember those as a kid. We have Facebook. We had taxis. And now we got people who have resources, their cars that they do. We have Uber. We have hotels, but now there's Airbnb. People are using an unused resource, their house when they're on vacation or whatever. We had currency, but really now we're seeing Bitcoin starting to take a place. And in fact, the market cap is astronomical at this point. And we see this decentralization that's occurring. And what we would like to do this is for supercomputers, QuantumStack would like to do this. How are we thinking about this? Let's look at traditional supercomputers. Now, these are 2016 numbers, but Sunway was the fastest supercomputer in the world at $273 million, 93 plus petaflops. I believe it's a little bit 115 now, something of that nature. Reports vary. That is a paid-for big supercomputer in China. Folding at Home, a project for folding proteins done out of Stanford. And look what they have. They have a crowdsourced, no payment supercomputer at 78.4 petaflops. Not too far apart. And in fact, both of these now are over 100 petaflops. So we know the crowd can get interested. But we may be...
It is, ladies and gentlemen, that greed, for lack of a better word, is good.
You remember this from New Wall Street. So the thing about the crowd computing, when you think about it, it's what's missing from something like a protein at home to actually make this a really big trend is economics. And what we want to do is we want to add the economic component. How are we going to do that? Well, let's think a bit about Bitcoin versus, let's say, Pleiades. Might not be a completely fair comparison, but we want to make it for you. And let's just think about the Bitcoin network. Now, the Bitcoin network, for those who don't know about Bitcoin, let me just give a 2-second history on it, or 2-second idea. It's been about a decade. And what occurs is there are miners. These are computers out in the world, and they're mining Bitcoin. And they do that by actually computing a hash. And the first guy who computes the hash wins. And the next couple of people who verify that, once that's won, it gets put in what's called a blockchain. And you get the coin. That's roughly what occurs in Bitcoin. It is a digital currency. It's gotten a lot of press. And it actually puts that number in what's called a blockchain. So let's look what happens. In the last 10 minutes, and this number changes, quite frankly, it's nearly doubled since we actually submitted our proposal, which is sort of an unusual idea. The actual network power has almost doubled. The Bitcoin mining network has deployed the equivalent of 141 years of NASA Pleiades work. Stop and let that sink in for a minute. In the last 10 minutes, the computational power of the Bitcoin network, when you compensate for operations and whatnot, the best of our understanding, it did about 141 years of NASA Pleiades work for about $35,000. And I can say $35,000 because in that 10 minutes time, it produced 12.5 Bitcoins, and they had a value of approximately $35,000. Now, this is an optimal market. This became an arms race. It went from your home computer to servers to FPGAs to what's now custom hardware. We don't actually believe that we can get this out of the gate, but it does show what happens when you add economics to a crowd issue. So what are we thinking about here? Traditional supercomputers, big buildings, capital budgets, staff, facilities, air conditioners, generators. We all know about this as big data center stuff. What are we looking at? We have really effectively no capital budget, no staffing or minimum staffing, no facilities, no air conditioners, no generators, no fixed cost per se when you think about it. Because we're using other people's computers. So our goal is to pull together all the free unused cycles out there. Think about it this way. On-demand, distributed, secure supercomputing. And we don't believe that by any chance that this will actually get rid of computers like Pleiades. We actually believe it'll supplement them. There certainly are classes of problems that this lends itself to. And in fact, we think there's probably some buildup of problems that aren't being addressed because they just can't get supercomputer time. And so we see these in conjunctions with that, but this is a distributed computational utility. How does it work? It works this way. Subscribers, we could say, let's say NASA, submits a problem and some money to the network. We'd work with them to partition that problem into a bunch of little pieces. We could call them quantum if you'd like, maybe for QuantumStack. We'd queue it out into the world. We'd probably queue it to a dozen computers just for resiliency purposes. We compare the results when they come back. If 3 miners equal, the first 3 to do, we've claimed that's done. That portion of the problem is done. We use the blockchain as proof of work. It's a ledger, and it allows us to say that this computer cryptographically has done this work. That is proof of work, so when we go to pay, we know exactly who we got to pay. Once we get all the results together, we return them to NASA, let's say in this point, and then we pay the miners. And then we start again on the next problem. Where do we think it'll work? Well, NASA has plenty of problems that they're working on, everything from astrometrics, orbits calculations, we actually think AI, all sorts of stuff that NASA does in this, and quite frankly, in merit in some ways in the commercial market. We also think there's some other things here. Getting STEM education up. I mean, we talked earlier about the fact that you had to hire young engineers on a project because it was going to go so long. Mission to Mars sounds a bit like that, right? We need people who can do this work. So we think this will be useful for STEM education as well, and many other commercial pieces. And we believe that we can provide unprecedented fidelity and speed to solution. Who are our competitors? There's a number of competitors in the market, if you want to look at it this way. One axis here is the competitors of basic architectures, as cloud security, Amazon, and Azure. There are also folding at home. Those are the free guys that are doing work, and SETI and those people. There's a few other people who are looking at the same idea. The difference is we're going to do it decentralized and secure. We're going to generalize the problem, build a piece of software that allows you to do more than just sort of a vertical problem, and we're going to use nominal capital investment to do it. We bring together skills, big diverse skills of people, computer science, high performance computing, people who have actually worked and done work in the Bitcoin and economics, that part of the market as well. We bring those together, cybersecurity, user experience, and game development, because we actually have to have that experience that the end user is going to want to give us their computer with. There's 4 of us working on this problem. Here's the founders. We have advisors. We have a local university, Old Dominion University. The chair of the department is one of our advisors. And we have several of their high-performance computing people, specifically people who are focused on algorithm and problem partitioning, because we think that's going to be part of the key to delivering this and distributed systems. We have business advisors in our midst as well. We are using a local company, SDC, is a longtime NASA contractor and actually does work here locally and at other centers as well, who's on our business advisor. We have the local enterprise and entrepreneur center over at ODU, who's helping us with the basic business pieces that we're doing. What do we need from NASA? Well, we need problems. You got problems? Certainly even problems that are probably undiscovered that's going to go to Mars, to mission to Mars, and we'd like to solve some of those problems. We could certainly use help with industry relationships. You have those. We certainly would love to have those because we know it's important to take advantage of the hardware we have. Public outreach and awareness as we do it. We actually think this might be a big key. I mean, one way to engage the public in a mission to Mars is to say, hey, do a little bit of the problem with your home computer. And I think there's a PR there that probably should be explored, but to say, hey, public, my computer did a little bit of work. And I think that would be sort of an interesting thing to do. We think the FAR, the acquisition, federal acquisition regulations, we think that it doesn't cover this, so we got to need some help to try to figure out how that works in the FAR. We don't really know how that works, but we've looked at it and kind of threw up our hands and said, well, maybe y'all can help us do that. The FAR is, if you know what it is, it'll twist your brain. Investors who are in the room, we could certainly use strategic partners. You may very well have in your Rolodex people who could use our service as well. That would be very important to us. And certainly startup funding. We're like any startup. We always need money, I guess. Our milestones, where are we? We think it's about a 9-month path we're on. At this point, we're working the alpha piece of what we're doing. We're starting to break down the problem and look at how we're going to do containerization and security and whatnot. We have some of this working in our distributed lab, distributed garage lab, as one might say. And but we certainly are moving as fast as startups do. What are we looking for our financial projections? We think we got about a 9-month incubation period where we're going to do some tests and test runs. We think at the end of year 1, we could probably be approaching 8 major problems and maybe something about 500,000 subscribers on the platform. Year 2, we're looking at 16 major problems. Year 3, maybe 32 major problems. Probably smaller stuff in the mix as well that's going on there, but it's general. We think in about 3 years and a bit, it's by Southern, and a bit, it'll be about $30 million, give or take. And that is our pitch from QuantumStack, and be glad to take any of your questions. Yes, sir.
You did mention on that you SETI at home, which has been going for about 10 or 12 years.
Yes.
I've used on my home desktop.
Yes.
Your system, you say that the architecture is more specialized. How would your architecture be different from my desktop?
So the difference in sort of the SETI at home project and folding in home project and whatnot is, if you think about these are vertical applications, very discrete vertical applications that have been designed specifically to solve a specific problem. And what we'd like to do is generalize that sort of interface to allow you to send out into the network of computers a broader set of problems. Now, we understand that when you get into tight coupling of things, we have a tight couple of memory or that kind of stuff. That's probably not the use for this. It's more for a loose coupled type problem. But your point is well taken. What we really want to do is build that interface that allows for a broader set of problems to be pushed out into the network. And that's the difference between probably us and SETI at home. And hopefully scale. We certainly like to be bigger than them.
Two questions for you. One, you talked about the miners. Are they active participants in the problem solution, or are they just providing computational resources?
They're providing computational resources in our vision. So basically, It's like SETI. They download an application. We suspect that something like a NASA problem would be a nice PR. That's a reason for them to potentially do it. That sort of makes sense. Mission to Mars would be a great reason for them to do it when you think about it. And they're passive to some extent. I do believe it is an opportunity to actually send information down and say, this is how much you've contributed, look at what the whole project's doing, here's a picture from Hubble, whatever. I think there's some of that kind of communication that can go on and off between the pieces, but effectively they're passive from their activity other than installing the software.
Okay, and a second question, you didn't talk much about it on the front end. When somebody brings a problem to you, there's some amount of activity and effort associated with translating their problem into something that can be solved via this process. Is that something you do? Is it something they're supposed to do?
Well, I'll be honest with you, you know more about your problems than we do. So my sense is it's a joint effort. We have an infrastructure, we have ideas about how we believe those problems will be actually implemented and done, and I think actually we're going to have to, certainly in the early days, work together to get some vertical, what are your needs going to be? And so my sense is initially we'll work together on it. And then over time, I believe we will actually end up with sort of a library of things, sort of standard stuff that we can reuse over and over and over again. But initially, let's be honest, it's going to have to be that way. Yes, ma'am. May I share that with you in the offline? Okay. This is being recorded for a public office, so yes, sir.
Yeah, maybe it's a related question and maybe also needs to be talked offline. I'm trying to get my handle on, you show up with a problem, is that $1 million problem, a $50,000 problem? How do you develop, or maybe it's a strategy on how the estimate of the amount of effort it would take to work the problem?
It's a good question, and we've been looking and modeling that problem. We know that roughly commercial outsourced supercomputers are roughly run at the level of, say, 12 cents a core per hour, roughly is what the market is sitting at right now, up plus or minus a penny or two. So at some level, it's going to have to be an estimate of the problem size, and we would certainly have to work with you to figure that out. I mean, we wouldn't know offhand. And at some level, we're also talking about adding resiliency and replication to the problem to make sure the solution is done. So we have models that we've been working on. Certainly you could help us refine those, our thinking on that. And quite frankly, understanding where the economics works for you in the end. Yes, sir.
Have you looked at the data migration? How much data can you transfer each way before it stops making sense?
It's a good point. We have done some initial work at looking at it. I would say we need more work on it. I will say this, there have been some open source projects that actually have looked at the internet. Same sort of idea. You harness a bunch of computers and you sort of, if you want to think about it, stripe the storage across a dozen computers and send it on the internet and whatnot. And it gets pretty decent performance. Let's be honest, it's going to be asymmetric, and so that's part of the calculation that the application has to do. It's got to determine what the link speed is and the CPU and all that kind of stuff. And so our goal is to sort of scale that based on, higher speed links with higher speed computers are going to get a little bit more work than the guys who are running a bit lower speed. But it's a very good point and something that we know that we have to work on the modeling for as well. We are modeling it, not perfectly yet. Yes, sir.
Yeah, thank you for your presentation. Do you foresee legal aspects in this distributed environment when moving and protecting information nationally or internationally?
It's certainly at some point we have to figure out what the legal piece is going to be, and maybe the real question is what would a service level agreement be in an environment like this? And it's certainly, let's be honest, we're charting new territory. I don't know that anybody particularly knows at some level, but we know that it's been done, and it's been done for many projects, and at some level the question is, can we raise the quality of what we're doing to the level that will provide the service? I think the service level agreement is the first piece. I think the second piece was already been pointed out, security of data. Now, one way to think about this, if the problem is partitioned in a lot of little pieces, just having a little piece of it probably isn't very interesting to some extent. Maybe even having a little piece of the mathematics isn't particularly very useful at some level. So you'd have to actually, have a very, very large scale attack of doing a bunch of stuff to actually get probably any significant information, even if the information was, just out in the open to some extent. We expect to secure it, encrypt it in the container and whatnot, encrypt it on its way back. But it's a very good point and something that on the list of the startup to go look at. So. Others? Thank you very much. Thank you for your time.